In the darkness of night, when we look up at the sky, the stars seem like the final boundary of human understanding. Yet, in truth, they are only the portion of light that has managed to reach human eyes. Beyond those points of light may exist regions of space so vast that all numbers lose their meaning. Science has taught us how to measure the distances between galaxies, calculate the age of the universe, and trace time back to the moment of the Big Bang. But the more we measure, the more we encounter a truth that is both unsettling and mesmerizing. Perhaps the universe itself lies beyond the reach of human measurement. So where is the true boundary of reality? Or is this a question beyond every measuring tool? Have you ever wondered if the universe is not just bigger than we imagine, but bigger than anything we can ever measure, no matter how advanced we become? This is the quiet question hiding behind every telescope image and every cosmic headline, because modern science is built on measurement, length and time and mass and energy. We take comfort in rulers and clocks and equations, yet the moment we try to wrap them around the universe as a whole, our tools begin to slip from our hands like sand. We can measure the distance to the moon with lasers. We can map the motion of nearby stars with astonishing precision. We can estimate the ages of ancient star clusters and the expansion rate of space itself. And still, the hardest part is not the calculation. It is the boundary of what can ever be known by light that reaches us. As Stephen Hawking once urged, remember to look up at the stars and not down at your feet. Because when you look up long enough, you start to sense a limit that is not emotional, but physical. Light does not travel instantly, and the universe has an age, which means there is only so far information can reach us since the beginning of cosmic time as we understand it. Imagine standing on a shore at night holding a lantern. The ocean is real beyond the reach of your beam, but your eyes cannot confirm it directly. The edge of your light is not the edge of the sea. It is the edge of what you can verify from where you stand. Our situation in cosmology is similar, except the ocean is space-time itself, and the lantern is every photon that has managed to cross billions of light-years and arrive here. This is why the idea of an observable universe matters so much, because it tells us not the size of everything, but the size of what we can receive signals from. Beyond that horizon, there may be more galaxies than we can count, more structures than we can name, perhaps even regions where the cosmic story unfolded in ways we will never witness. Carl Sagan captured the humility of this perspective with a line that still feels like a scientific prayer. Somewhere something incredible is waiting to be known. Yet even that hope carries a shadow, because some incredible things might be waiting in places that cannot ever send their message to us. When people hear this, they sometimes assume it is just philosophy wearing a lab coat, but it is not. It is a consequence of how space-time works and how information travels. To make it tangible, think of a vast city during a blackout. You stand on one rooftop and see only the neighborhoods where a few generators still glow. You can map those lights accurately. You can estimate how many buildings exist in that lit region. You can even infer patterns of streets and blocks. But the darkness beyond is not proof of emptiness. It is proof that your line of sight has limits. In the same way, we can point to galaxies and say, we see them as they were long ago, and we can measure how space has expanded between then and now. We can even build a cosmic distance ladder using reliable rungs like Cepheid variable stars and Type Ia supernovae and the subtle imprint of the cosmic microwave background. These are triumphs of careful measurement, and they deserve respect. But they do not guarantee that the whole universe is within reach of measurement. In fact, the deeper we go, the more we collide with a hard truth. The universe can be larger than the portion that can ever communicate with us. Here is another image that helps people feel it in their bones. Imagine being a character inside a novel written on an endless scroll. You can read the lines around you. You can study the grammar and predict patterns, but you cannot unroll the entire scroll at once. Your knowledge is local. Your certainty is bounded by what is physically accessible. Cosmologists face a similar predicament, and the most honest ones do not hide it. As Albert Einstein put it, the most incomprehensible thing about the universe is that it is comprehensible. That sentence contains both wonder and restraint, because comprehensible does not mean fully graspable, and measurable does not mean complete. There is also a subtle twist that makes the question even sharper. The universe is not only old and vast, it is expanding. And if space itself stretches, then two regions can separate so quickly that light emitted today from one region will never reach the other. This is not science fiction. It is a straightforward implication of cosmic expansion and the presence of what we call dark energy in the standard model of cosmology. An everyday analogy is standing on a moving walkway trying to walk the wrong way. If the belt moves faster than you're walking, speed, you can never reach the point you aim for, even though it is not forbidden in principle. If space between us and a distant region grows in the relevant way faster than light can make headway, that region slips beyond our future ability to measure it directly. This is where many people suddenly feel a chill, because it means the universe might be not merely unmeasured today, but unmeasurable forever in its full extent. And yet, the story is not despairing. It is clarifying. It tells us what science is and what it is not. Science does not claim omniscience. It claims disciplined honesty about what evidence can support. That honesty is why this question is powerful, because it forces us to distinguish between what exists, what can be observed, what can be inferred, and what can be proven to a standard we accept. Let me offer 3 concrete examples that make the scale and the limit intuitive without turning it into abstract math. First, consider hearing thunder. You can estimate the distance of a storm by timing the delay after lightning. But if a storm is too far away, its sound will not reach you at all, even though the storm is real and violent and full of energy. In cosmology, light is our thunder, and there are storms of creation and destruction beyond the range of any signal we can receive. Second, consider a foggy night drive. Your headlights reveal a reliable slice of the road, but not the entire highway network beyond the fog wall. The limit is not your intelligence. It is the medium and the physics of visibility. Third, consider the deep ocean from a boat at noon. The sea surface can look calm and complete, but beneath it exists an entire world of trenches and mountains and currents that remain unseen without special instruments. The observable universe is our surface view, and the unobservable may be a depth we can only infer indirectly, if at all. These examples do not prove the universe is infinite, but they help us accept the idea that measurement is not the same thing as totality. Now we come to the part that I consider personally the most meaningful, because it changes how we tell the story of human knowledge. We often speak as if progress means conquering ignorance inch by inch until nothing is left hidden. But cosmology suggests a different picture. Progress might mean mapping our island of certainty more accurately, while acknowledging the ocean beyond it might have no shoreline we will ever touch. In that sense, our best instruments do not remove mystery. They refine it. Every time a new telescope opens a deeper view, we do not merely collect more facts. We discover new boundaries of what is in principle reachable. That is why a line attributed to Sagan continues to resonate with scientists and storytellers alike. We are a way for the cosmos to know itself. It suggests that even if we are confined to a horizon, the act of understanding inside that horizon matters on a cosmic scale. And to me, this is where the lesson becomes surprisingly practical. To me, this is where the lesson becomes surprisingly practical. If the universe may be larger than anything we can measure, then certainty is not a trophy. It is a responsibility. It teaches intellectual humility, not as weakness, but as strength. Because the moment we admit limits, we become more careful with what we claim, more patient with what we do not yet understand, and more open to the possibility that reality is richer than our current models. That is also why the best scientists often sound unexpectedly lyrical when they speak about the cosmos. When Neil deGrasse Tyson says, "The universe is in us," he is not abandoning science. He is pointing to a measurable fact with emotional consequences. The atoms in our bodies were forged in stars and scattered by ancient explosions. The statement is grounded in astrophysics, yet it also reminds us that we belong to the story we are trying to measure. And that belonging matters when we ask a question like this, because we are not outside observers holding a tape measure to a distant object. We are inside the thing we are attempting to comprehend, like a sailor trying to chart the ocean while standing on a moving deck beneath a sky that has no visible wall. At this point, some viewers will ask a sharp and fair question. If we cannot measure beyond the horizon, does it even make sense to talk about it? I think it does. And not because we want fantasy, but because careful inference is a legitimate scientific method when direct access is impossible. We infer the existence of unseen planets by the wobble of stars. We infer the existence of black holes by the motion of nearby matter and the bending of light. We infer the existence of dark matter from the way galaxies rotate and clusters hold together. In each case, we take what is measurable and follow it to the edge of its implications. The key is to keep the language honest, to say perhaps unlikely and consistent with the evidence, rather than to pretend we have photographed what cannot yet be photographed. So when we speak about a universe larger than what we can measure, we are not claiming a final answer. We are acknowledging that our best models allow room for an immensity beyond direct verification. And that brings us back to the opening idea with sharper clarity. This is not a vague philosophical puzzle. It is a scientific question about information and limits and horizons. We can measure stars and galaxies, and even the relic glow of the early universe with extraordinary success. And those measurements are among the most impressive achievements of human civilization. Yet the very same physics that empowers these measurements also warns us that we might never measure the whole. I find that paradox deeply moving, because it means the universe invites us to know it, and simultaneously reminds us that knowledge will always be partial. It is like walking through a cathedral of darkness with a candle. Each step reveals new stonework and hidden carvings, yet the ceiling remains lost in shadow. The candle is not useless. It is sacred precisely because it is limited. If I add my own perspective, as someone who writes science for people who are tired and human and searching for meaning, I would say this question offers a gentle correction to the modern instinct to control everything. We live in a time where data is abundant, where maps seem complete, where answers arrive instantly on a screen. The cosmos refuses that mindset, not by mocking us, but by inviting us into a longer patience. The lesson I take is simple. Measure what you can with rigor. Hold your conclusions with humility. And let the unknown enlarge your character rather than shrink your confidence. Because awe is not the enemy of reason. Awe is what keeps reason honest. And perhaps that is the most persuasive outcome of this whole idea. That the universe may be larger than anything we can measure, yet our desire to measure it is still worthwhile, still dignified, still profoundly human. So I will leave you with the question that hangs quietly over every calculation and every image from deep space. When our finest instruments reach their ultimate horizon, will we accept that boundary as the edge of reality? Or will we treat it as the beginning of the greatest mystery of all? A question beyond every measuring tool. What does it truly mean to measure something in a universe where information must travel, where distance is not just space but time, and where even the act of knowing depends on a fragile chain of physical rules holding steady across billions of light years? We often speak about measurement as if it were simple and absolute, as if the cosmos were a room and we could pace it out with a ruler. But the reality is more delicate, more conditional, and in a strange way more beautiful. To measure anything at all, 3 quiet requirements must be met. First, the thing must produce information in some form: light, heat, radio waves, gravity's influence. Second, that information must actually reach us, crossing whatever emptiness or plasma or dust lies between. Third, the laws of physics must remain stable along the journey, so that the signal arriving in our instruments still means what it meant when it was emitted. That is the hidden contract behind every astronomical fact we think we know. When that contract holds, the universe becomes readable, like a book written in photons and spectra. When it fails, the universe becomes silent, not necessarily empty, simply unreachable. This is why the speed of light is not just a number in a textbook. It is a boundary on knowledge itself. As Albert Einstein expressed in his own way, the speed of light is woven into the structure of space-time, not merely a property of a beam in the dark. And once you accept that speed is finite, you also accept something unsettling. There are places so far away that their information has not had time to arrive. And there may be places from which information will never arrive at all, because the universe expands and carries them beyond our reach. In cosmology, light is our supreme measuring tool, because it is the messenger that travels best across cosmic distances. Yet its greatness is inseparable from its limitation, because light takes time, and time is not infinite for any observer anchored in a universe with an age. Stephen Hawking once wrote that we are like fish in a bowl, trying to understand the nature of reality beyond the glass. And whether or not you take that metaphor literally, it captures the humility forced upon us by measurement. We can learn astonishing things, but only through the window that physics allows. Consider how astronomers measure a star's temperature, not by touching it, but by splitting its light into a spectrum and reading the pattern like a barcode of energy levels. That measurement requires the star to emit light, requires that light to survive the journey through space, and requires that the atomic physics shaping that spectrum in the star's atmosphere is the same atomic physics we test in laboratories on Earth. When those conditions align, the universe becomes not only visible, but quantifiable. Now imagine the same logic applied to a galaxy so distant that its light is stretched by cosmic expansion into visitum, infrared wavelengths. We can still measure it, but only if we build instruments sensitive enough to detect that shifted light. This is why a telescope is not merely a bigger eye. It is a translator adapting our senses to the messages the universe can still deliver. But now imagine a region so far away that no photon from it can ever reach us. Not today. Not in 1 trillion years. In that case, measurement collapses not because our technology is weak, but because the universe has placed a wall of causality between us and that region. This is the meaning behind the simple claim that light is finite in speed. It sets the horizon of evidence. To help people feel this without equations, I like to use a handful of everyday images that preserve the logic of the cosmos without watering it down. Picture a lighthouse on a foggy coast. Its beam is real, and it travels forward. But the fog makes a boundary where the light simply fades from your view. The ocean beyond the fog does not stop existing, but from where you stand you cannot measure the shape of distant waves. You cannot confirm the presence of a ship beyond that veil. The fog is not ignorance. It is a physical limit on information reaching your eyes. Now picture an earthquake happening on the far side of a continent. You might detect its waves if you have sensitive instruments. But if you are too far and the waves dissipate and the signal is lost in noise, then the event is effectively unmeasurable to you even though it happened. In astronomy, the signal is light or radio waves or gravitational influence, and the noise can be distance itself, intervening matter, or the expansion of space stretching signals thinner and thinner until they vanish into the background of the universe. Here is another example that many listeners grasp immediately. Imagine hearing a whisper in a crowded stadium. The whisper exists. It contains information, but it cannot reach you with enough clarity to be measured as meaningful speech. Some cosmic signals are like that whisper. Their photons arrive, but are so few and so stretched and so drowned in noise that the information cannot be extracted with confidence. Measurement is not just reception. It is interpretation backed by physical stability and statistical reliability. What if the biggest limitation in astronomy is not the size of our telescopes, but the simple fact that reality can only be known through messages that manage to reach us? Intact, interpretable, and still governed by the same physics we trust here on Earth. When we say we can measure something in the universe, we often picture certainty, a clean number, a confident distance, a neat age. Yet measurement is not a magic power. It is a fragile relationship between an object and an observer, held together by information and time. To measure any cosmic thing at all, 3 quiet conditions must be satisfied. The object must produce information, the information must reach us, and the laws of physics must remain stable along the entire path so the message does not change its meaning before it arrives. If any link breaks, the universe may still be there, but it becomes unreadable to us in practice. This is why the speed of light is not merely a constant in a formula. It is a boundary carved into knowledge itself. Light is the supreme measuring tool in cosmology because it is the most persistent messenger across interstellar and intergalactic distances. But its speed is finite. and that single fact makes measurement conditional on time and reach. We do not see objects as they are right now in some absolute sense. We see them as they were when their light left them. When you look at the moon, you see it as it was about a second ago. When you look at the sun, you see it as it was minutes ago. And when you look at a galaxy, billions of light years away, you see an ancient chapter of cosmic history that may have no direct connection to the present state of that galaxy today. There is a calm honesty in that fact, and it is the kind of honesty that makes science trustworthy. Galileo is often credited with a line that captures the spirit of measurement without pretending it is effortless. The universe is written in the language of mathematics. But mathematics does not float free of evidence. It relies on signals and stability, and the discipline of not claiming more than the universe has actually told us. The first condition is that something must emit information, and in astronomy the most familiar form is electromagnetic radiation, light across the spectrum from radio to gamma rays. Stars glow. Gas clouds shine in characteristic colors. Dust re-radiates heat as infrared light. Exploding stars flash as brilliant transients that can be seen across vast distances. Even when an object is dark in visible light, it can still announce itself through other messengers, like radio jets near black holes or the gentle microwave whisper left over from the early universe. Yet if an object emits almost nothing that can escape its environment, or if what it emits is absorbed immediately by surrounding matter, then measurement becomes a struggle from the first step. The second condition is that the information must reach us, and here the universe can be cruel in its elegance. Space is transparent in many wavelengths, but not all. And even in transparent windows, the signal weakens with distance. Photons spread out, the same way a voice becomes faint, across a large field. Add intervening dust that blocks visible light. Add gas that absorbs certain frequencies. Add the simple fact that very distant light is stretched by cosmic expansion into longer wavelengths. And you start to see how reaching us is not guaranteed. The third condition is the most subtle and the most sacred to scientific reasoning. The laws of physics must behave consistently from there to here. When we read the spectrum of a star to infer its temperature and composition, we assume that the same atomic transitions we measure in laboratories also occurred in that star's atmosphere. When we interpret redshift as evidence of cosmic expansion, we assume space-time operates in the same basic way across the observable universe. This assumption is not blind faith. It is tested repeatedly by the remarkable consistency of physical laws in observations across cosmic time, but it remains a condition we must keep in mind with humility. Now let these conditions become real through images your mind can hold. Imagine standing on a dark beach with a lantern. The ocean continues far beyond your beam, but your measurement ends where the light ends. The boundary is not the ocean's edge. It is the edge of information reaching your eyes. Imagine driving at night in dense fog. Your headlights reveal a trustworthy slice of road, but the highway beyond the fog wall is not erased. It is merely beyond your ability to confirm from that position. Imagine listening for a whisper in a crowded stadium. The whisper exists and carries information, yet it cannot be separated from noise enough to be measured as meaning. In cosmology, many signals are exactly like that. They arrive too faint, too distorted, too stretched, too drowned in background to yield reliable numbers. What makes this especially profound is that our best measuring tool is also the reason we will never measure everything. Light takes time, and the universe has an age. So there is a natural horizon to what can have reached us since the beginning. But cosmology adds another twist that makes the limit even sharper. Space itself expands. If space between us and a sufficiently distant region expands in the relevant way, then even a photon launched today may never arrive here. This is not a failure of technology. It is a feature of space-time. You can picture it like trying to swim upstream on a river that accelerates as you go. There comes a point where the current outpaces your maximum speed, and the destination becomes unreachable, even though it exists. This is why the phrase "cannot be measured" does not automatically mean does not exist. It can simply mean cannot send us information in a usable form. Carl Sagan offered a line that remains one of the most responsible ways to hold both wonder and restraint at once. Somewhere something incredible is waiting to be known. The hidden companion to that sentence is that some incredible things may never be known directly by us, because knowledge requires a messenger that can arrive. Even within the measurable realm, our numbers are built on carefully linked methods. We infer distances using standard candles like Cepheid variable stars and type Ia supernovae. We measure cosmic expansion using redshift. We cross-check models with the cosmic microwave background, that faint afterglow from the early universe that fills the sky almost uniformly. Each method depends on the three conditions continuing to hold: emission and travel and stable physics. When a supernova explodes in a distant galaxy, it must shine in a predictable way. Its photons must traverse intergalactic space, and the fundamental behavior of light and atoms must remain consistent, so we can interpret the brightness and spectrum correctly. This is why measurement is not merely detection. It is interpretation, grounded in physical law and repeated verification. It is also why expert voices so often emphasize humility rather than triumph when they speak about cosmic knowledge. Richard Feynman warned in a sentence that should be printed above every claim of certainty. The first principle is that you must not fool yourself. In cosmology, this becomes a kind of meditative discipline, to remember that what we measure is only what the universe has allowed to be communicated to us, and to remember that the unmeasured is not automatically the unreal. There is another messenger that makes this story even richer: gravitational waves. They are not light, but ripples in space-time itself. When detectors on Earth sense these waves from merging black holes and neutron stars, we are measuring the universe with a different kind of ear. Yet even here, the same three conditions apply. The event must generate a signal. The signal must reach us. And the physics connecting source to detector must remain consistent enough to decode what we heard. Each new messenger expands the portion of reality that becomes measurable, but none of them abolish the basic limit that information must arrive. And so the deeper truth emerges. Measurement is not just about instruments. It is about access. You can build a better telescope. You can cool detectors to near absolute zero. You can place observatories in space beyond atmospheric distortion. But you cannot force a photon to arrive from a region that is causally disconnected. You cannot demand evidence from beyond a horizon that space-time itself has drawn. This is where the topic becomes almost spiritual without leaving science, because it asks us to accept that reality can be larger than evidence, and that knowledge is not a conquest of everything, but a faithful reading of what is available. That acceptance does not weaken science. It strengthens it by keeping it honest. I want to add a personal view from the perspective of someone who writes science for human minds that want clarity but also need meaning. I think this three-condition idea is one of the most liberating truths in all of cosmology, because it rescues us from the illusion that intelligence means total control. In daily life, we often treat measurement as power. If we can measure it, we can manage it. The universe offers a gentler lesson. We measure what we can, not to dominate reality, but to participate in it with care. The act of measuring becomes an act of listening, a disciplined attention to signals arriving from the deep past. It teaches patience, because cosmic information takes time. It teaches modesty, because our window is finite. And it teaches gratitude, because the fact that any messages reach us at all is extraordinary. When I think of the cosmic microwave background, that faint radiation that has traveled since the early universe and still lands on our detectors today, I feel a strange tenderness toward the cosmos, as if the universe left us a postcard from its childhood. Not everything sends postcards. Not everything can be heard. And that is the final lesson I would offer to your audience. Do not confuse the edge of measurement with the edge of existence. The universe is not obligated to be fully measurable to be real. And we are not diminished because we cannot reach it all. In fact, the recognition of limits is a mark of maturity in both science and spirit. So, when someone asks what it means to measure something in cosmology, the most truthful answer is not a number. It is a relationship. A signal is born. It survives a long journey. It arrives in a fragile instrument, and we interpret it using laws we believe remain stable across the abyss. That is measurement, a bridge of information across time. And the question that should linger as the doorway to the next part of the story is this: if everything we know depends on messages that can reach us, what kinds of realities might exist beyond the last message we will ever be able to receive? Have you ever stared into a deep space image and felt a quiet shock? Not because of what you saw, but because of what you suddenly realized you could never see. The phrase observable universe sounds modest and technical, yet it hides one of the most emotionally powerful facts in modern science: that the universe we can observe is not the universe in full. It is the portion of reality whose light has had enough time to reach Earth since the beginning of cosmic time as we describe it. That single detail changes everything, because it means our grandest cosmic map is still a map drawn from one shoreline. When we say the observable universe has a radius of about 46.5 billion light-years, while the universe is about 13.8 billion years old, many people feel a contradiction. How can something be larger than the distance light could travel in the age of the different universe? The answer is that space itself has been stretching while the light was on its way, like a long road that grows longer even as a traveler walks it. The traveler keeps moving forward, but the landscape beneath their feet expands. So the distance to the source today can be vastly larger than the distance the light actually traversed at any single moment in the past. This is not a trick of language. It is a direct consequence of an expanding universe described by general relativity and confirmed by multiple lines of evidence in modern cosmology. A simple example makes it feel real without heavy mathematics. Imagine dots on the surface of a balloon, and imagine the balloon being inflated. No dot needs to move across the rubber by itself for every dot to become farther from every other dot. The surface itself grows, and the distances grow with it. Or imagine raisins in a loaf of rising bread. As the dough expands, each raisin sees all the others receding is less than $0.5. Dollar is greater than not because they are crawling away. but because the medium between them is swelling. In cosmology, the dough is space, and the raisins are galaxies. This is the intuition behind why the observable universe can be so much larger than 13.8 billion light-years in radius, even though light has traveled for 13.8 billion years since the early universe became transparent enough for photons to stream freely. There is a reason this topic keeps returning in the minds of scientists and storytellers alike, because it forces us to separate two ideas we usually blend together: reality and accessibility. The observable universe is not the biggest thing that exists. It is the biggest thing that can have informed us by light and other messengers within cosmic time and cosmic expansion. It is the boundary of what can be in causal contact with us in the simplest sense of information exchange. If you want a human-scale metaphor, think of standing on a beach and looking at the horizon. The ocean continues beyond that line, but your eyes cannot confirm its texture or its waves beyond the curve of Earth and the limitations of light and atmosphere. The horizon is not the end of the sea. It is the end of what you can verify from where you stand. In the same way, the cosmic horizon is not a wall at the edge of existence. It is the edge of the information that could have reached us so far. Carl Sagan captured the emotional posture that fits this reality with a sentence that remains both humble and brave. Somewhere, something incredible is waiting to be known. The observable universe is the stage where that knowing can happen for us. And it is already more vast than any mind naturally comprehends. When you realize how far 46.5 billion light-years is in every direction, you start to sense why cosmology can feel like meditation. It stretches the self until it becomes quieter. Yet even this immense sphere is not guaranteed to be the whole universe. That is the deeper point your script is aiming toward, and it is scientifically responsible. The observable universe is a subset of the total universe, and the total may be far larger, is less than $0.5 is greater than possibly unimaginably larger. We do not claim this as a dramatic certainty. We treat it as a sober implication of how horizons and expansion work and how limited any observer must be in a universe with finite age and finite signal speed. Now let the listener feel how measurement becomes a story told in light. Every galaxy we see at extreme distance is a message from deep time. The photons arriving tonight began their journey when Earth had no humans to witness them, when continents were shaped differently, when the Milky Way itself was younger. In that sense, astronomy is not just looking outward. It is looking backward is less than $0.5. Dollar is greater than because distance and time are braided together by the finite speed of light. This is why Edwin Hubble's discovery that galaxies appear to recede on average is not merely a historical detail. It is a doorway into the concept that our cosmic map is dynamic rather than static. The observable universe is not a frozen globe of objects. It is a living horizon, shaped by expansion and time and the physics of propagation. If you want the audience to picture the 46.5 billion light-year radius in an intuitive way, offer them a mental model of nested rooms of visibility. The first room is the solar system, where distances feel almost manageable, light minutes and light hours. The next room is the Milky Way, where distances become tens of thousands of light-years. Then the local group and clusters, where distances become millions of light-years. Then the cosmic web, where filaments and voids stretch across hundreds of millions of light-years. Finally, the farthest light we can see from near the beginning of the transparent universe draws the boundary of the observable region is less than $0.5. is greater than a sphere whose radius is about 46.5 billion light years today, because the space between then and now has expanded while the light traveled. The beauty here is that each step is built from real measurement methods is less than 0.5 is greater than standard candles and redshift, and the cosmic microwave background number 0.5 is greater than, and each step also reminds us that measurement is always inside the horizon of communication. From my perspective, the lesson is not that science fails to reach everything. The lesson is that science tells the truth about what it can reach and what it cannot, and that truth is a form of integrity. The observable universe is not a defeat. It is a carefully drawn boundary line that protects us from pretending we have knowledge we do not have. It teaches intellectual humility in a way that is almost calming, because it frees us from the burden of total certainty is less than 0.5 is greater than, and replaces it with a disciplined awe that says, know what can be known, and be honest about the rest. Richard Feynman expressed the spirit of this honesty with a warning that fits cosmology perfectly. The first principle is that you must not fool yourself. In this topic, fooling ourselves would mean treating the observable universe as the full universe simply, because it is the largest thing we can currently describe with evidence we can receive and interpret. So, what should the listener carry forward as a practical takeaway from a concept that sounds abstract? I would say it offers a gentle correction to how we live in a world addicted to control is less than 0.5 dollar is greater than numbers, is less than 0.5 dollar is greater than, and instant answers. The cosmos reminds us that some boundaries are not obstacles to be smashed but horizons to be respected. The observable universe is vast enough to humble any ego, yet it is also intimate in one surprising way, because it is defined by a relationship between the universe and us. It is the portion of reality that has reached our eyes and instruments as evidence since the Big Bang is less than 0.5 dollar is greater than the portion that has spoken to us in photons and spectra and ancient radiation. And the final thought that makes this feel like a story rather than a statistic is simple. Every time we look outward and measure what we can, we are not just mapping space, we are listening to time and learning to live with the difference between the universe we can see and the universe that may exist beyond our last reachable light. Have you ever wondered why the farther we look into space, the more it feels like the universe is quietly stepping backward from our reach? On a clear night, the sky looks open and generous, as if all of it is waiting to be known. Yet there is a boundary woven into reality itself, a horizon not made of walls or clouds or darkness, but made of time and speed and the relentless swelling of space. Cosmologists call it the cosmic horizon, and the idea is simple and terrifying at the same time. Beyond a certain distance, light will never reach us. Not because the light is weak, not because the journey is unfinished, but because the space between us and the source grows too fast. The universe expands, and in some directions, it expands in a way that outpaces the ability of photons to close the gap. It is like trying to swim toward a shore that is steadily drifting away faster than any swimmer can move. The tragedy is not that we are slow. The tragedy is that the shoreline is escaping by the rules of the ocean itself. This is why the phrase "we can never measure everything" is not pessimism. It is accuracy. We live inside a bubble of what can be observed, and the bubble has an edge defined by physics. Outside that edge may exist galaxies and structures and histories that are real but forever out of reach. If you need a picture for your mind, Imagine standing in a valley filled with thick fog at dawn. You can see nearby trees. Then shapes become uncertain. And beyond a certain line, the world does not end. It simply stops sending you information. The cosmic horizon is that line, except the fog is time and expansion. And the hidden landscape may be unimaginably vast. Another example is more intimate. Think of a lighthouse on a coastline that keeps receding while its beam travels across the water. The beam is still moving at the same speed, but the distance it must cross keeps increasing. At some point, the beam can be perfectly bright and still never arrive. That is what it means for light to never reach us, because space expands too quickly. And now the most important consequence, the one that makes audiences sit up straighter. It means the cosmos could contain regions far beyond our observable universe, with their own galaxies, their own collisions and births of stars, perhaps even their own long unfolding stories. We are not saying they must exist. We are saying the horizon makes it possible that they do. This is where scientific humility becomes a kind of awe, because it forces us to admit a boundary not of engineering, but of causality. As the physicist Lawrence Krauss put it, we live in an age when we can learn about the universe by looking back in time with light. And yet there is a limit to how far back and how far out we can ever see. The late Stephen Hawking offered a sentence that fits here like a key in a lock. We are just an advanced breed of monkeys on a minor planet of a very average star. It sounds blunt, but the cosmic horizon gives it context and depth. We can be brilliant and still be bounded. We can be curious and still face a curtain that never lifts. And then there is Carl Sagan, whose voice still feels like a calm hand on the shoulder in the dark. Somewhere, something incredible is waiting to be known. The horizon does not cancel that hope. It sharpens it. Because it tells us that what we know is precious precisely because it is limited. Here is a third example to make the idea land cleanly. Imagine a library where books keep being printed on shelves that slide away from you on moving rails. You can read the nearby rows. You can even run and grab a volume a little farther down. But past a certain point, the shelves retreat faster than you can move. Those books still exist. Their pages still carry stories and facts and worlds. But the mechanism of the library forbids access. The cosmic horizon is that mechanism, written into space-time itself. When you say to the audience that there may be galaxies we will never measure, you are not using fantasy. You are using the logic of light, travel time, and expanding space. This is also why astronomers talk about the observable universe rather than simply the universe. The observable universe is not a guess. It is a defined region from which light has had time to reach us since the hot beginning. And because space has expanded while that light traveled, the boundary is farther than a naive calculation would suggest. What fascinates me personally is how the horizon changes the emotional meaning of discovery. Every new telescope feels like a victory. Every deeper image feels like we have broken another lock. Yet the horizon whispers that there will always be a last lock we cannot pick. That is not discouraging to me. It is clarifying. It means our work is not to conquer the universe, but to listen to the part that can speak to us. It means science is a conversation with what can reach us. And wisdom is accepting that some truths will remain silent, not because they are mystical, but because they are causally disconnected. There is a quiet moral lesson hiding here, one that belongs in a documentary voice that is both scientific and human. If the cosmos itself contains unreachable regions, then certainty should never become arrogance. We should be confident in what evidence supports, and gentle about what we cannot test. The horizon teaches a kind of intellectual compassion, reminding us that limits are not failures. They are features of the world we inhabit. And there is also a strangely comforting thought. When people worry that their lives are small, I think of the horizon, and I remember that even the universe keeps secrets from itself in a sense. Two regions can exist in the same cosmos and never exchange a single photon. So perhaps meaning is not about touching everything. Perhaps meaning is about the depth with which we touch what is near enough to be real to us. When you speak this to an audience, you can feel their attention change. The cosmic horizon turns astronomy into something like a meditation on boundaries, on patience, on the discipline of not pretending we know what we cannot possibly know. It also creates a sense of urgency that is oddly beautiful. Because the universe does not only have a horizon in space, it has a horizon in time. As expansion continues, more distant galaxies slip beyond reach, their light becoming fainter, their signals stretched and diluted. In the far future, a civilization might look out and see a lonelier sky than we see today. That idea makes this moment feel rare, like standing in a brief clearing of cosmic history when the view is wide enough to inspire real understanding. So the lesson I would leave the listener with is not despair, but gratitude and focus. We have access to a universe that speaks through ancient light, through microwave afterglow, through the slow gravity of galaxies and the sudden flash of exploding stars. We should listen carefully, measure honestly, and admit where measurement ends. And if there truly are unreachable galaxies and structures beyond the cosmic horizon, then the most reasonable response is not to invent certainty, but to deepen wonder. Because the horizon is not a wall that insults us. It is a boundary that defines our human condition. We are creatures who can ask questions larger than our instruments, and that may be the most astonishing fact of all. What if the universe is finite, yet has no edge to fall off of? No final wall, no last sign that says stop here. That single idea sounds like a riddle, and yet it is one of the most practical questions in modern cosmology. Because the moment you ask whether the universe is finite or infinite, you are also asking what it means to measure anything at all, what it means to have a horizon of knowledge, and what it means to live inside a reality that may be larger than every tool we can ever build. The strange part is that a universe can be finite without having an edge, and the simplest way to feel that truth is to picture the surface of Earth. Earth has a limited area, and yet if you walk long enough you do not arrive at a cliff where the world ends. You arrive at more Earth. Over and over. Ocean becomes continent. Continent becomes mountain. Mountain becomes desert. And still there is no border drawn into the fabric of the surface itself. This is not magic. It is geometry. A sphere is finite but unbounded on its surface. And the moment you accept that such a thing can exist in everyday life, your imagination becomes ready for a universe that might behave in a similar way. Now take that Earth example and quiet your mind for a second, because it is easy to misunderstand it. The analogy is not saying the universe is a sphere floating in something else, like a ball in a room. It is pointing to a deeper possibility. That space itself could be curved in a way that gives it a total size, while still offering no edge to reach. If you were a tiny ant living on a vast rubber globe, every direction would look like forward. There would be no sign of curvature in the ant's immediate neighborhood unless it traveled far enough and measured carefully enough. In the same way, we might be living in a cosmos whose local neighborhood looks flat, while the full shape of space is something we can only infer from subtle clues in the sky. This is where the current measurements become so important. When cosmologists measure the large-scale geometry of space using the cosmic microwave background, the afterglow of the early universe, the result so far is that space appears extremely close to flat. Flatness here does not mean boring. It means that the rules of Euclidean geometry work astonishingly well on the largest scales we can test. Parallel lines behave like parallel lines. Triangles add up the way we expect. And the overall curvature seems near zero within the limits of uncertainty. If that flatness is exact, one natural mathematical possibility is an infinite universe. Not infinite in the sense of endless matter packed everywhere as far as you can go with a ship, but infinite in the sense that there is no final coordinate where space stops being space. Yet even if space is nearly flat, it could still be finite if its topology is unusual, like a three-dimensional version of a video game world that wraps around. Imagine you fly straight in one direction, and after an unimaginable journey, you return from the opposite side without ever turning around. To you, there was no wall, no boundary, only continuity. This example is not a claim that the universe definitely wraps like that. It is a way to help the mind hold a concept that physics still treats as open. And it leads to a startling conclusion. The universe could be vastly larger than the observable universe, even if it is finite. The observable universe is not the whole universe. It is the portion whose light has had time to reach us since the hot beginning. Beyond that horizon could lie more galaxies, more structures, perhaps regions with the same physical laws, perhaps regions with the same patterns repeating only because the universe is so large that repetition becomes likely in a statistical sense. This is where I always pause, because the numbers stop feeling like numbers and start feeling like weather. You can describe a storm with data, but you understand it in your bones only when the wind hits your face. In the same way, saying the universe could be thousands or millions of times larger than what we can see is correct in spirit. But the lived meaning is different. It means our cosmic map may be a postcard cropped from a continent we will never finish exploring. It means the most honest scientific sentence might be, we do not know how big the hole is, only how big our window is. And yet we keep trying, because that is what minds do when faced with darkness that might contain order. Stephen Hawking once offered a line often quoted in science communication: "Look up at the stars and not down at your feet." The exact wording is sometimes reported with slight variations, but the spirit is consistent. Lift your gaze toward the large questions. Carl Sagan is also widely remembered for another short invitation. Somewhere something incredible is waiting to be known. Again, the phrasing may differ depending on the source, but the meaning is steady. Curiosity is not a hobby. It is a human duty to reality itself. And Albert Einstein left us a thought that remains painfully relevant to this discussion. The most incomprehensible thing about the universe is that it is comprehensible. Even if you have heard it before, sit with it. Because the question of finiteness and infinity is exactly where comprehension begins to wobble. Yet it never fully collapses. We can test the geometry of space with ancient light, We can model how structure grows from tiny fluctuations. We can compare predictions to what telescopes actually see. But there is a boundary we cannot step over. The boundary set by light, travel time, and cosmic expansion. No matter how advanced our instruments become, we cannot receive signals from beyond the cosmic horizon if the expansion of space keeps those regions causally disconnected from us. That is not a limitation of funding. It is a limitation of the universe itself. And this is the most important emotional turn in the story. The universe might be finite with no edge, or infinite with no end. And in both cases the same lesson appears. We are not at the center of the map. We are inside the map. And the map may be bigger than any lifetime of measurement. To make it more tangible, imagine standing on a beach at night, with a flashlight that can reach a few hundred meters before fading into mist. You can measure everything your beam touches: grains of sand, shells, footprints. But the coastline does not end where your light ends. The darkness is not a wall. It is a limit of access. The observable universe is our flashlight beam. Beyond it may be more shore, more ocean, perhaps the same physics continuing, perhaps surprises we cannot yet imagine. Another example is to picture a ship crossing Earth before global navigation existed. A sailor could measure the sea around them with ropes and stars, could chart islands and currents. Yet the ocean extended beyond their charts. Not because it was mystical, but because knowledge expands slower than reality does. When I bring my own perspective into this, I find it strangely calming. The possibility of an immeasurably larger universe does not make life meaningless. It makes arrogance impossible to defend. It turns certainty into a softer material, something you hold carefully, instead of swinging like a weapon. And it changes how you interpret the word boundary, because boundaries are not always fences in the world. Sometimes they are simply the edge of what you can currently touch. The practical scientific takeaway is clear. Flatness measurements suggest that if the universe is curved, it is curved so gently that the total size could be enormous compared with what we see. The philosophical takeaway is even clearer. We should live as if reality is larger than our convictions. Because it probably is. And so the story circles back to the original question. Not as a puzzle to solve in one video, but as a doorway to a lifelong way of seeing. If the universe is finite, it may still have no edge. If it is infinite, it may still be structured and lawful in ways we can partially understand. Either way, the observable universe is not a prison. It is a starting line. And the quiet lesson I carry from all this is simple. Measure what you can, admit what you cannot, and let that honesty make you kinder, more patient, and more awake to the vastness that holds us. What if the universe has no edge at all? Not because we have not discovered it yet, but because there is nothing like an edge to discover. This single thought quietly destabilizes how we normally think about space, distance, and meaning. When people hear the phrase "an infinite universe," they often imagine something exaggerated and dramatic. A colossal container stretching endlessly outward, galaxy after galaxy, light year after light year. Yet the versions of infinity taken seriously in cosmology are far more subtle and far more unsettling. They describe a universe with no center to stand in, no rim to approach, and no outside into which the cosmos is expanding. In this view, space itself is the thing that exists everywhere. Modern cosmology arrives at this idea not through philosophy, but through mathematics and observation. General relativity allows space to be curved or flat, finite or infinite. And when astronomers measure the large-scale structure of the universe, the pattern of galaxies, and the faint afterglow of the Big Bang, the results suggest a cosmos that is remarkably close to perfectly flat. A flat geometry does not prove infinity, but it allows it naturally. This is where the question becomes delicate, because infinity is not something we can ever observe directly. No telescope can zoom out far enough to confirm that space never ends, because light itself travels at a finite speed. The observable universe is limited by time, not by walls. We see only as far as light has had time to reach us since the Big Bang. Beyond that cosmic horizon, information is permanently cut off. Not hidden, not waiting for better technology, but fundamentally unreachable. This means that even if the universe extends forever, every measurement we ever make will describe only a small bubble of reality. The physicist Stephen Hawking once expressed this idea with striking simplicity when he suggested that a universe with no boundary does not need an outside or an edge to exist. It simply is. That statement removes the comforting picture of a cosmic frame around everything, a final border where questions stop and certainty begins. If there is no boundary, then there is no privileged direction that leads to the end of existence, and no special location that can claim to be the center of all things. To help visualize this, consider the surface of Earth. It is finite in area, yet you can travel forever without encountering an edge. There is no point on the planet that is objectively the middle of the surface. Every location is local. Now remove the third dimension from that surface and imagine living entirely within it. Your measurements would be accurate and meaningful locally, but they would never reveal a boundary. Or imagine standing on a beach at night, watching the lights of a ship fade into darkness. The ocean does not end where your vision fails. Your ability to see does. The cosmic horizon works the same way. It is not a physical edge, but a limit imposed by time and expansion. Inflation theory pushes this idea even further, suggesting that space expanded so violently in the early universe that vast regions were separated forever before light could connect them. If that picture is correct, then the portion of the universe we observe may be an unimaginably tiny fragment of the total whole. In that case, infinity is not an abstract fantasy, but a natural outcome of well-tested physical principles extended beyond our horizon. Still, science remains careful. Cosmologists do not claim to have proven infinity. They acknowledge where evidence ends and extrapolation begins. This honesty is one of science's greatest strengths. It allows us to say with confidence what models permit, while admitting what cannot yet be confirmed. From a personal perspective, this idea carries a quiet lesson. If the universe truly has no center, then our importance cannot come from location or scale. We are not special because we occupy a privileged place, but because we are capable of asking questions that stretch beyond our measurements. The possibility of an infinite universe invites humility, but also wonder. It reminds us that knowledge does not require total possession of reality, only honest engagement with the part we can reach. And Perhaps the most meaningful insight is this: a universe that may be larger than anything we can ever measure does not diminish human curiosity. It dignifies it. Because in acknowledging the limits of our rulers and equations, we demonstrate the very intelligence that allowed us to discover those limits in the first place. Have you ever wondered whether the universe can grow so vast that measurement itself loses all meaning? At first, this sounds like a philosophical puzzle, but it arises directly from one of the most serious ideas in modern cosmology: the theory of cosmic inflation. According to this idea, in the earliest fraction of a second after the Big Bang, space itself expanded at an extraordinary rate, far faster than the expansion we observe today. This was not matter flying through space, but space itself stretching, carrying everything with it. Regions that were once unimaginably close were torn apart so quickly that no signal, not even light, could ever cross the growing distance between them. From that moment onward, those regions became permanently separated in practice. They may still exist, but they no longer belong to the same observable reality. This idea reshapes how we think about the size of the universe. What we call the observable universe is not the whole cosmos. It is only the region from which light has had enough time to reach us since the beginning. Inflation suggests that this visible region could be a tiny island in a far greater ocean of space. Even before inflation is considered, the observable universe already contains hundreds of billions of galaxies, each with hundreds of billions of stars. Yet inflation quietly implies that everything we see may be only a small patch of a much larger fabric. Not because our instruments are weak, but because the structure of space-time itself places a hard limit on what can ever be measured. Alan Guth, one of the physicists who first proposed inflation, once remarked that the observable universe may be only a tiny fraction of the whole. This statement is not meant to diminish observation, but to clarify its meaning. Measurement depends on connection, and inflation breaks connections at the most fundamental level. When space expands faster than light can travel, distance becomes absolute separation. No future technology can overcome that barrier, because it is not a wall in space. It is the way space behaves. To visualize this, imagine dots painted on the surface of a balloon. If the balloon inflates slowly, the dots drift apart and can still exchange signals by crawling along the surface. But if the balloon suddenly expands explosively, some dots rush away so fast that no signal traveling along the surface could ever catch up. From the perspective of any one dot, those others effectively vanish from the accessible universe. Inflation is like that sudden expansion, but happening to space itself. This leads to a deeply humbling conclusion. There may be regions of the universe that are not merely far away, but fundamentally unreachable. They are not hidden behind dust or darkness. They are hidden behind the geometry of space-time. And yet, their existence still influences our understanding of what the universe is. Stephen Hawking once emphasized that inflation would have left subtle imprints on the universe we observe, not as direct images, but as patterns in the large-scale structure and the faint afterglow of the early cosmos. These traces suggest that space was stretched smooth and vast in its infancy. What makes inflation especially powerful is that it explains why the universe looks so uniform on large scales. Distant regions that appear similar today may have once been close enough to share conditions before inflation drove them apart. In this sense, inflation is both an explanation and a warning. It explains the smoothness we see, but warns us that similarity does not imply proximity anymore. The universe may repeat patterns far beyond what we can ever verify. From a personal perspective, this idea changes how I think about knowledge. We often assume that with enough time and technology, every mystery can be solved. Inflation suggests otherwise. There may be truths that are real, physical, and governed by the same laws, yet permanently beyond confirmation. This is not a failure of science, but a reminder of its honesty. Science does not promise omniscience. It promises disciplined curiosity within known limits. The lesson here is not despair. It is humility. Inflation teaches us that reality is likely far larger than our experience, and far richer than our measurements. At the same time, it shows how much can still be learned from the small region we inhabit. By studying subtle patterns in cosmic radiation and galaxy distribution, we infer events that happened when the universe was younger than a heartbeat. That alone is extraordinary. In the end, cosmic inflation invites a quieter form of awe. Not the awe of seeing everything, but the awe of knowing that there is more than can ever be seen. It asks us to accept that our cosmic home may be one chapter in a story too large to read in full. And perhaps the deepest insight is this: the value of understanding does not come from reaching the edge of the universe, but from learning how to think clearly and humbly within a universe that may have no edge at all. What if the largest thing we will ever try to understand is also the one thing we can never fully see? Not because our telescopes are weak, but because the universe itself is structured around a fundamental limit: the finite speed of light. Every measurement in cosmology begins with light, because light is how information travels across space and time. We measure distance by how long light has been traveling. We measure motion by how light is stretched or compressed. And we measure history by how ancient that light appears when it reaches us. Yet the deeper we explore the cosmos, the more clearly we see a paradox. Some parts of the universe may exist forever beyond the reach of light itself. And when light fails, science does not surrender. It changes language. Mathematics steps in, not as a substitute for reality, but as a way to reason about what reality might be doing beyond our direct perception. This shift is subtle but profound, because mathematics is not a camera. It does not capture images. It is a system of logic that allows us to extend patterns observed here into regions we cannot see. And that extension rests on a quiet assumption: that the laws of physics we test locally continue to hold universally. This assumption is extraordinarily reasonable, but it remains an assumption nonetheless. George Box expressed this humility perfectly when he said that all models are wrong but some are useful. In cosmology, usefulness means coherence, consistency, and predictive power. When equations describe galaxy motion, cosmic expansion, and relic radiation from the early universe with remarkable precision, we trust them not because they are perfect, but because they keep working. Stephen Hawking once wrote that our ultimate goal is a complete understanding of the universe and our place in it. Yet even he acknowledged that such understanding would always be provisional, shaped by the limits of observation and imagination. To make this idea tangible, imagine standing on a vast plain at night, holding a lantern that illuminates only a small circle around you. Within that circle, you can measure everything precisely: the ground texture, the slope, the distance between stones. Beyond the light, darkness begins. You cannot see what lies there, but if every step within the circle shows the same terrain, you naturally infer continuity beyond it. This is not blind faith. It is disciplined expectation. Cosmology works the same way, except the lantern is the observable universe, and the darkness is everything beyond the cosmic horizon. We cannot travel to that horizon, and no signal from beyond it may ever reach us. Still, patterns within our reach are astonishingly consistent. Spectral lines from distant galaxies obey the same atomic rules measured in laboratories on Earth. The speed of light appears constant across billions of light years. General relativity predicts gravitational effects that match observations from solar systems to galaxy clusters. These successes give weight to the assumption of universality, but they do not turn it into certainty. Another everyday analogy helps clarify the point. A doctor diagnosing an illness rarely sees the disease directly. Instead, they infer its presence from patterns in symptoms, test results, and prior knowledge. The diagnosis is rational, evidence-based, and often correct. Yet it always carries uncertainty. In cosmology, unseen components like dark matter and dark energy are inferred in much the same way. Vera Rubin showed that stars in galaxies move too fast to be held together by visible matter alone. Gravitational lensing reveals mass where little light exists. The equations insist on additional ingredients, not because mystery is attractive, but because the math refuses to balance without them. Eugene Wigner famously called this the unreasonable effectiveness of mathematics in the natural sciences. It captures a sense of awe shared by many scientists, that abstract symbols can describe reality with uncanny precision. But this effectiveness carries a risk: the temptation to mistake the map for the territory. Mathematics can describe countless logically consistent universes, but only one corresponds to the world we inhabit. This is why cosmology remains anchored to observation, even while it reaches far beyond it. Measurements of the cosmic microwave background, power, distribution of galaxies, the abundance of light elements, and the expansion rate of space all serve as fixed reference points. From these points, equations extend outward into the unknown, always tethered, never free-floating. The most honest line in your original idea is the acknowledgement that this entire structure rests on an assumption, a very good one, but still an assumption. This is not a weakness, it is a strength, because it keeps science open to surprise. The discovery that cosmic expansion is accelerating shattered comfortable expectations. The ongoing tension in measurements of the Hubble constant hints that something in our current framework may still be incomplete. From my own perspective, the lesson is clear. Mathematics is the most disciplined form of imagination humans possess, allowing us to think beyond our senses without drifting into fantasy. But its power depends on humility, on remembering where inference ends and measurement begins. We do not use mathematics to claim dominion over the universe. We use it to listen carefully to patterns that reality reveals. And perhaps the deepest lesson for the listener is this: the universe does not owe us full visibility. Understanding does not mean seeing everything. It means knowing how far our light reaches, and how responsibly we reason beyond it. What if the greatest discovery in cosmology is not what we have seen, but what we can never verify? When people hear the phrase "beyond the cosmic horizon," it can sound like a dramatic metaphor, but in modern physics it is a hard boundary drawn by light speed and cosmic expansion. No telescope, not even the James Webb Space Telescope with its extraordinary infrared vision, can look past that boundary. And it is not because our engineering is weak. It is because the universe itself sets the rules of access to information. The cosmic horizon is not a wall made of stone. It is a limit on communication, a limit on evidence, a limit on what can ever arrive here in the form of light or any signal that travels at or below light speed. In the simplest terms, if something happens far enough away and the expansion of space separates us fast enough, the message can never reach Earth. That is the quiet shock hiding inside your lines. No signal from outside can come to us, and therefore some regions of reality may exist forever without our confirmation. If you want a picture to hold in your mind, imagine standing on a calm beach at night, watching a ship sail away until it slips below the horizon. The ship still exists. It still moves. But the curve of the Earth hides it from your eyes. Now enlarge that idea from Earth curvature to space-time geometry and cosmic expansion, and you are close to what cosmologists mean by a horizon. Or imagine a dense fog in a valley, so thick that even a bright lighthouse becomes a faint glow and then disappears entirely with distance. The lighthouse does not turn off. The fog simply refuses to deliver the information to you. In the early universe there was something like that fog. Not water droplets, but a hot plasma where light scattered constantly. And that is why the farthest electromagnetic light we can directly observe is not a scene of the very beginning, but the cosmic microwave background. The afterglow released when the universe cooled enough for light to travel freely. We can hear people say we see back to the beginning. Yet even here, the universe reminds us that there are chapters sealed behind physical conditions that no telescope can undo. That is why the statement "no telescope can see beyond the cosmic horizon" is not a pessimistic slogan. It is an honest measurement of what evidence can cross into our world line. Stephen Hawking once urged people to lift their gaze upward, saying in essence that meaning begins when we look to the stars rather than down at our feet. Carl Sagan offered another kind of encouragement when he said that somewhere something incredible is waiting to be known. Those lines endure because they capture the emotional posture science demands: humility without surrender, wonder without fantasy, curiosity with discipline. Yet the cosmic horizon teaches a harder lesson than wonder alone. It teaches that knowledge is not only limited by intelligence or technology, but also by the structure of reality itself. Here is an everyday example that makes the logic almost painfully clear. If you stand in a canyon and shout, there is a distance beyond which your voice cannot be heard because the sound dissipates and the terrain blocks it. Your words do not become false. They simply fail to arrive. Replace sound with light. Replace canyon with expanding space-time, and the principle remains. Another example is radio communication in deep space. Spacecraft signals weaken with distance until they sink below the noise floor of the universe. If we were far enough and space expanded in the wrong way, even a universe shouting its history could become silent to us. This is why people sometimes misunderstand what James Webb can do. It can see extraordinarily faint and ancient galaxies. It can push closer to the earliest eras than previous observatories. But it cannot break the logic of horizons. It is like building the finest microscope on Earth and asking it to show you what lies behind a locked door on the far side of the planet. The problem is not magnification. The problem is access to the information stream. The most sobering implication is also the most fertile for storytelling and meaning. If there are regions beyond our horizon, they could contain galaxies and structures and histories that will never be part of our evidence base. They might look broadly similar to what we see, or they might differ in ways we cannot anticipate. And we must admit the boundary honestly. We do not know, and we may never know by direct observation. That does not make cosmology weak. It makes it mature. A mature science knows where the edge of inference lies, and it labels the edge clearly instead of pretending it is not there. There is a subtle beauty in that restraint, because it protects us from turning our models into myths. And yet the horizon does not end the story. It redirects it. We can still learn about what we cannot see by studying what the visible universe implies. The geometry of space, the patterns in the microwave background, the distribution of galaxies, the fingerprints of expansion history. We can test models against data and reject what fails. And in that way we build a map of the possible even when we cannot step beyond the border. This is the moment where my personal view enters the frame, because I do not experience this limit as discouragement. I experience it as a kind of cosmic ethics. It reminds me to treat every confident statement with care, to separate what we have measured from what we have inferred, and to keep a space inside the mind for honest uncertainty. In daily life, that practice is rare and precious. We are trained to perform certainty even when we do not possess it. The horizon teaches the opposite, discipline, to say this is what we know, this is how we know it, and this is where knowing becomes guessing. There is also a quiet consolation hidden here, because the universe does not demand that we conquer every mystery to live meaningfully inside it. It offers us enough to study for a lifetime and beyond, and it keeps some distance as a reminder that reality is not built for our convenience. If you want one last image, imagine a vast library where the lights only illuminate the shelves within a circle around you. You can read thousands of books with rigor and joy. You can cross-check them and build theories and correct yourself. But beyond the circle there are other shelves in darkness, and the building is so large that you may never reach them. The darkness is not an insult. It is part of the architecture. And so the lesson I take from your passage is both scientific and deeply human. We should be ambitious in measurement, relentless in verification, and modest about what verification can ever touch. When we accept that some parts of the universe may forever evade direct proof, we do not shrink. We grow calmer, clearer, and more careful with truth. And that returns us to the single haunting idea that can carry an entire video like a steady heartbeat. If no signal from beyond the cosmic horizon can ever reach us, what else is happening out there right now? In regions of reality that will never leave a trace in our sky? What if the most honest sentence science can say is not "we know"? But we cannot know yet. When we stand beneath a clear night sky, the stars appear like answers scattered across a vast darkness. Yet the deeper we look, the more we realize that reality does not promise full access to the human mind. Science never claims that beyond our instruments there is nothing. It claims something far more disciplined and far more humble. That with the methods available today, we cannot confirm what lies beyond certain boundaries. This is not a failure. It is an act of intellectual honesty that prevents curiosity from turning into illusion. Carl Sagan once warned that extraordinary claims require extraordinary evidence, and within that sentence lives a quiet safeguard against humanity's oldest temptation: the desire to replace uncertainty with comforting stories. Richard Feynman echoed the same wisdom from another direction when he said that he would rather have questions that cannot be answered than answers that cannot be questioned. In this spirit, science does not rush toward final truths. It walks carefully toward better questions. Stephen Hawking reminded us of this humility when he wrote that every physical theory is always provisional, only a hypothesis that has survived testing so far. The universe may stretch far beyond imagination, but the true wonder lies in our willingness to say precisely where evidence speaks, and where it falls silent. Imagine standing on a ship surrounded by dense fog. Your lights carve a narrow tunnel through the mist. Within that tunnel you can measure distance, speed, and movement with confidence. Beyond it there may be open ocean, cliffs, or other vessels traveling unseen. But integrity means you do not invent a shoreline simply to ease uncertainty. The observable universe functions in much the same way, limited not by what exists, but by what information has had time to reach us. Light travels at a finite speed, and the universe has a finite age. So our cosmic view is shaped like a bubble defined by causality. Beyond that horizon may exist galaxies, structures, or realms entirely unfamiliar. Yet, current methods cannot bring them into observational reach. History offers a powerful reminder that not knowing is often temporary. Think of the microscopic world before the invention of lenses. For centuries, humans debated disease as curse, imbalance, or fate, not from ignorance, but from the absence of tools. When microscopes improved, bacteria crossed the threshold from speculation to measurement, transforming medicine and human survival. This teaches us that some limits are technological, waiting patiently for better instruments. Yet other limits are woven into the nature of reality itself. Werner Heisenberg expressed this boundary when he observed that what we observe is not nature itself, but nature exposed to our method of questioning. At quantum scales, measurement becomes interaction, and knowing one property precisely obscures another. Even with perfect instruments, certain knowledge remains constrained by fundamental principles. There is also a quieter limit we rarely acknowledge: the architecture of the human brain. Our senses evolved to navigate one planet, one temperature range, one scale of motion. We do not intuitively perceive curved spacetime, expanding space, or probabilistic reality. We reach them through mathematics, symbols, and abstract reasoning. This does not weaken knowledge. It reveals how extraordinary the act of understanding truly is. When I reflect on these limits, I feel not despair, but calm. There is peace in accepting that the universe does not fit inside human certainty, and dignity in continuing to explore regardless. The most dangerous moment in the history of thought is not when we admit ignorance, but when we deny it. Entire civilizations have mistaken their best models for final truth, silencing new questions that threatened comfort. Science at its best resists this impulse. It builds confidence only where evidence accumulates, and restraint where it does not. Saying we cannot know with current methods is not a wall. It is a compass, pointing toward future discovery. Gravitational waves once existed only on paper, predicted by equations, and doubted for decades. Today they are measured whispers from colliding black holes, proof that silence can eventually become signal. Exoplanets followed a similar path, once philosophical possibilities, now counted by the thousands through precise observation. In each case, the unknown did not disappear. It retreated, opening deeper horizons. The lesson I draw personally is simple and demanding. Humility is not the enemy of ambition. It is its foundation. In science, as in life, certainty feels powerful, but honesty is stronger. Accepting limits sharpens curiosity, disciplines imagination, and preserves wonder. A universe with boundaries to knowledge is not smaller, it is richer. When you carry this understanding beneath the stars, they cease to be mere objects and become reminders that reality exceeds grasp yet invites inquiry. Science is the lantern we carry into darkness, not a promise that the darkness ends nearby. Its value lies in illuminating faithfully, not pretending completeness. Perhaps the deepest lesson is this: knowledge is not possession, it is relationship. A careful dialogue between evidence and humility. When we say we cannot know yet, we are not closing the book. We are marking the page where future minds will continue reading. What if the greatest discovery we can make is not a new number, but the place where numbers stop working? On a clear night, when you lift your eyes into the dark canopy of space, it is tempting to believe that the universe is simply a bigger map waiting for better instruments. A longer tape measure, a sharper telescope. Yet the deeper we go into modern cosmology, the more we meet a profound possibility: that the universe may be larger than anything we can ever measure directly. Not because we lack intelligence, not because we lack courage, but because reality itself places a horizon between what exists and what can be reached by information. Light does not travel infinitely fast, and the cosmos is not standing still while it travels. The result is humbling and strangely beautiful. There may be regions of space whose light will never arrive here, no matter how long we wait. That does not make those regions unreal. It simply means our relationship to them is forever indirect. And in that realization, our position as a species becomes smaller than our pride wants to admit, yet larger than despair would allow. Because to recognize a limit is not weakness. It is a form of wisdom. It is the moment the mind stops pretending to own the world and begins learning how to live inside it. Carl Sagan offered a quiet anchor for this feeling when he said, "Somewhere, something incredible is waiting to be known." Notice the humility in that sentence. It does not promise that everything will be known. Only that wonder remains justified. Stephen Hawking spoke to the same tension between ambition and modesty when he reminded us, "Remember to look up at the stars and not down at your feet." Looking up does not guarantee mastery, but it trains the soul to accept scale without surrendering meaning. And that is where the heart of your idea truly lives. If the universe is beyond complete measurement, then our role is not to dominate it, but to interpret the portion we are allowed to touch. Think of a ship at sea on a fog-heavy night, with instruments that can chart only a circle of water around it. Beyond that circle, the ocean still exists. Waves still rise and fall. Storms still form and dissolve. Yet the crew cannot map them in real time. The wise captain does not deny the unseen ocean, and does not panic at it either. He navigates by what can be measured and respects what cannot. Our observable universe is that circle of water, defined by the finite speed of light and the history of cosmic expansion. The cosmic horizon is the fog line, not a wall of nothingness but a boundary of contact. Another example is more intimate. Imagine standing in a desert at night with a small lantern. The circle of light tells you where you can safely step, and beyond it there is not emptiness but mystery. Dunes and stones and distances your eyes cannot confirm. The lantern is our physics, our telescopes, our detectors, and also our mathematics. It lights a real region of truth, and it also exposes the existence of darkness beyond its reach. That darkness is not an enemy. It is a reminder that reality is not obligated to be fully accessible to any one viewpoint. If you want a third picture that people instantly feel, think about the horizon on Earth, where the curve of the planet hides most of the surface from your eyes. The land beyond the horizon does not cease to be land. It simply waits for movement and time to become visible. In the cosmos, however, there are horizons that movement cannot cross because the expansion of space can outpace any journey we could make. This is not pessimism. It is precision. Science is at its most honest when it distinguishes between what is observed, what is inferred, and what is fundamentally unreachable by information transfer from that region to us. Here is where your message becomes powerful for an audience, because it does not merely say we are small. It says our smallness is the starting point of clarity. If we accept that we cannot control the universe, we stop wasting energy pretending we can own outcomes that belong to scale and chance. We begin to focus on what humans genuinely do well, building reliable models from limited data, testing them patiently, revising them without shame when new evidence arrives. Neil deGrasse Tyson captured this dignity of inquiry with a line many people remember: "The universe is under no obligation to make sense to you." It sounds stern, but it is actually liberating, because it removes the insult of not knowing and replaces it with the responsibility of learning properly. And Einstein gave us the emotional posture for that responsibility when he said, "The most beautiful experience we can have is the mysterious." Mystery here is not a marketing trick. It is a factual feature of a universe that may exceed measurement. My own view, speaking as someone who lives inside this subject day after day, is that the limit is not a closed door. It is a boundary that shapes a healthier kind of awe. When people hear that we might never measure the whole universe, they sometimes feel a brief sadness, as if the story ends before the final chapter. But I think the opposite is true. The story becomes more meaningful because it refuses to reduce existence to a checklist. If everything were measurable and fully mapped, wonder would shrink into routine, and curiosity would become mere accounting. Instead, we inhabit a cosmos where our knowledge is real and hard-won, and yet never final. That balance trains humility without erasing purpose. The practical lesson is simple and surprisingly tender. We do not need to control the universe to live wisely within it. We can control our attention, our honesty, our compassion, our willingness to revise beliefs when evidence changes. We can choose to be the kind of species that treats the known as sacred and the unknown as deserving of care rather than fear. When you say we can understand the part we are allowed to access, You are describing the best contract between humanity and reality. Limited data, unlimited meaning, if we learn how to listen. So let the audience feel it in their bones. The universe may be larger than any instrument we build, larger than any catalogue of galaxies, larger than the sum of our measurements. And yet, the very act of admitting that limit is a mark of intelligence, a calm strength rather than a defeat. We are not the owners of the cosmos. We are its witnesses, and perhaps its storytellers. If the universe truly cannot be measured in full, then the deepest human achievement is not to conquer it, but to meet it with clear eyes and a steady heart. And that leaves us with the question that keeps the entire journey alive. If there are vast realms we will never reach, what if the greatest discovery we can make is not a new number, but the place where numbers stop working? On a clear night, when you lift your eyes into the dark canopy of space, it is tempting to believe that the universe is simply a bigger map waiting for better instruments, a longer tape measure, a sharper telescope. Yet the deeper we go into modern cosmology, the more we meet a profound possibility, that the universe may be larger than anything we can ever measure directly. Not because we lack intelligence, not because we lack courage, but because reality itself places a horizon between what exists and what can be reached by information. Light does not travel infinitely fast, and the cosmos is not standing still while it travels. The result is humbling and strangely beautiful. There may be regions of space whose light will never arrive here, no matter how long we wait. That does not make those regions unreal. It simply means our relationship to them is forever indirect. And in that realization, our position as a species becomes smaller than our pride wants to admit, yet larger than despair would allow. Because to recognize a limit is not weakness. It is a form of wisdom. It is the moment the mind stops pretending to own the world and begins learning how to live inside it. Carl Sagan offered a quiet anchor for this feeling when he said, "Somewhere, something incredible is waiting to be known." Notice the humility in that sentence. It does not promise that everything will be known. Only that wonder remains justified. Stephen Hawking spoke to the same tension between ambition and modesty when he reminded us, "Remember to look up at the stars and not down at your feet." Looking up does not guarantee mastery, but it trains the soul to accept scale without surrendering meaning. And that is where your idea becomes powerful, because it does not merely say we are small. It says our smallness is the starting point of clarity. If the universe is beyond complete measurement, then our role is not to dominate it, but to interpret the portion we are allowed to touch. Think of a ship at sea on a fog-heavy night, with instruments that can chart only a circle of water around it. Beyond that circle, the ocean still exists. Waves still rise and fall. Storms still form and dissolve. Yet the crew cannot map them in real time. The wise captain does not deny the unseen ocean, and does not panic at it either. He navigates by what can be measured and respects what cannot. Our observable universe is that circle of water, defined by the finite speed of light and the history of cosmic expansion. The cosmic horizon is the fog line, not a wall of nothingness, but a boundary of contact. Another example is more intimate. Imagine standing in a desert at night with a small lantern. The circle of light tells you where you can safely step, and beyond it there is not emptiness but mystery. Dunes and stones and distances your eyes cannot confirm. The lantern is our physics, our telescopes, our detectors, and also our mathematics. It lights a real region of truth, and it also exposes the existence of darkness beyond its reach. That darkness is not an enemy. It is a reminder that reality is not obligated to be fully accessible to any one viewpoint. Neil deGrasse Tyson captured this dignity of inquiry with a line many people remember: "The universe is under no obligation to make sense to you." It sounds stern, but it is actually liberating, because it removes the insult of not knowing and replaces it with the responsibility of learning properly. Einstein gave us the emotional posture for that responsibility when he said, "The most beautiful experience we can have is the mysterious." Mystery here is not a marketing trick. It is a factual feature of a universe that may exceed measurement. My own view, speaking as a narrator who lives inside this subject day after day, is that the limit is not a closed door. It is a boundary that shapes a healthier kind of awe. When people hear that we might never measure the whole universe, they sometimes feel a brief sadness, as if the story ends before the final chapter. But I think the opposite is true. The story becomes more meaningful because it refuses to reduce existence to a checklist. If everything were measurable and fully mapped, wonder would shrink into routine, and curiosity would become mere accounting. Instead, we inhabit a cosmos where our knowledge is real and hard-won, and yet never final. That balance trains humility without erasing purpose. The lesson is simple and quietly practical. We do not need to control the universe to live wisely within it. We can control our attention, our honesty, our compassion, our willingness to revise beliefs when evidence changes. We can choose to be the kind of species that treats the known as precious and the unknown as worthy of care rather than fear. When we say we can understand the part we are allowed to access, we are describing the best contract between humanity and reality. Limited reach, unlimited meaning if we learn how to listen. So let this land with calm strength. The universe may be larger than any instrument we build, larger than any catalogue of galaxies, larger than the sum of our measurements. And yet the act of admitting that limit is itself a mark of intelligence, a steady humility rather than a defeat. We are not the owners of the cosmos. We are its witnesses, and perhaps its storytellers. If the universe truly cannot be measured in full, then the deepest human achievement is not to conquer it, but to meet it with clear eyes and a steady heart. And that leaves us with one final question to carry into the silence. If there are vast realms we will never reach, what kind of wisdom should we build with the small window of reality we are given? So we return to the question that has quietly followed us from the beginning. Is the universe larger than anything we can measure? The most honest answer science can offer today is not a number or a boundary, but a careful and disciplined possibility. Perhaps this is not a failure of knowledge. It is the natural outcome of taking evidence seriously and refusing to claim more than observation allows. Every telescope we build extends our reach, yet also sharpens our awareness of where that reach must end. The observable universe is not a declaration of completeness. It is a confession of limits written in light and time. Beyond it may lie regions that will never send a signal to us. Not because they are empty, but because the structure of space-time itself prevents contact. In that sense, the universe may be vastly larger than the story we can ever tell about it. And yet this realization does not diminish human meaning. It refines it. We are not diminished by the fact that we cannot measure everything. We are defined by our ability to recognize that truth without despair. The pursuit of science has never been about possessing total knowledge, but about learning how to ask better questions with intellectual honesty. When we accept that some aspects of reality lie beyond our instruments, we do not abandon understanding. We protect it from illusion. There is a quiet maturity in knowing that measurement is a tool, not a guarantee of completeness. Perhaps the deeper lesson is not that the universe escapes our rulers and equations, but that wisdom begins precisely where control ends. To live in a universe that may never be fully measured is to live inside a conversation rather than a conclusion. Each discovery expands the horizon, and each horizon reminds us that mystery is not an error in the system, but a fundamental feature of existence. And so the most important act may not be to reach the final boundary, but to carry ourselves with humility and curiosity within the boundaries we can reach. If there are realities beyond our measurement, then our task is not to conquer them in imagination, but to honor what we know and remain open to what we cannot yet touch. In that openness, science remains honest, humanity remains grounded, and the universe remains larger than any single answer we could ever give.